This topic is about problem solving with radians in order to calculate areas and perimeters of complex shapes. I will go through some examples. Feel free to pause whenever you wish. First thing I need to do is do a recap on everything that you need to know about this topic. So the first thing is the conversion, which is pi radians is equal to 180 degrees. The two formulae that you need for this topic is equal to arc length is equal to radius times theta, and area of sector is equal to half r squared theta, where theta is angle in radian. Okay, the other formula that you need that might be helpful are the sine rule, which is a over sine A is equal to b over sine B, which is equal to c over sine C. The cosine rule, which is a squared is equal to b squared plus c squared minus 2bc cosine A. And the last one is the area of a triangle rule, which is a is equal to half AB sine C. So these are for triangles. This is sector area, and this one is arc length. Okay, so let's go to the first example. A circular sector OCD subtending an angle theta radians at its center has a radius of r meters. The sector has an area of 0.25 meters squared and a perimeter of 2 meters. So area of sector is equal to 0.25 meters squared, and perimeter of sector is equal to 2 meters. Okay, the first thing I'll have to do is write out the equation for area of sector. So area of sector, the formula is half r squared theta. If I combine the area sector, the two equations I have for sector area, then I have half r squared theta must be equal to 0.25. The perimeter of the sector must be equal to r plus r plus the arc length here, which is r theta. So plus r theta. So that means if I simplify, I get 2r plus r theta. The formula I get when I equate these two things is 2r plus r theta, which is the perimeter of the sector, must be equal to 2 meters. Okay, if I rearrange, so this is equation 1, this is equation 2. If I rearrange equation 1, then I get r squared theta is equal to 0.5, if I double both sides, which means theta must be equal to 0.5 over r squared. If I substitute theta is equal to 0.5 over r squared into 2, I'm going to go over here, then I get 2r plus r times 0.5 over r squared must be equal to 2. Okay, if I simplify the second term, then I get 2r plus 0.5 over r is equal to 2. I multiply through by r to get rid of the denominator. I get 2r squared plus 0.5 is equal to 2r. If I take everything to the left-hand side, I get 2r squared minus 2r plus 0.5 is equal to 0. I don't like the decimal, so I'm going to double everything. So I get 4r squared minus 4r plus 1 is equal to 0. That looks like it's going to simplify. So 2r and 2r. If I put minus 1 and minus 1, I get 4r squared minus 4r plus 1, which means 2r minus 1 is equal to 0, which implies r is equal to a half. So r is equal to 0.5 meters. Now I need to also find theta. So since theta is equal to 0.5 over r squared, it must be equal to 0.5 over 0.5 squared. If I put that into my calculator, I end up getting 2, which means theta is equal to 2 radians. So that is the solution for that. So it's just setting up two equations and then solving it simultaneously. Next question. The figure above shows a circle with center at O and the radius is 12. The chord AB has a length of 12 root 3. Show that angle AOB, which is this one here, let's call that x, is 2 pi over 3. Okay, A. So because I've got this triangle here, because this is also the radius, this is also 12. I've got triangle 12, 12. We're trying to find this angle x. And I've got the other side is 12 root 3. Then I know I can apply the cosine rule. So we're going to use the version of the cosine rule where we're trying to find a missing angle. So cosine A is equal to b squared plus c squared minus a squared all over 2bc. So in our triangle, this is cos x is equal to 12 squared plus 12 squared minus 12 root 3 squared all over 2 times 12 times 12. If we put this into our calculator, we're at cos x is equal to minus a half. So x must be inverse cos of minus a half, which is equal to 2 over 3 pi. Okay, part B. Find in exact form the area of the major segment bounded by the chord AB. So the major segment means I need to find the area of this part. Okay, that part is separated into two. First part is area of the triangle. So I need to work out the area of the triangle and also the area of, let's change colors, green, the major segment. Okay, so let's work out first the area of the triangle. So part B, area of triangle, formula is half AB sine C, half AB sine C, which is half times 12 times 12 times sine of x, which we just worked out, which is 2 pi over 3, or 2 over 3 pi, however you want to write it. If you put this into the calculator, you get 36 root 3. Okay, now the area of the major sector, because we want the major sector, I need this angle. So if this is 2 over 3 pi, then this must be 2 pi take away 2 over 3 pi, because angle around a circle is equal to 2 pi, which gives me 4 pi over 3. So the formula I'm using is half r squared theta, which is half times 12 squared times theta, which is 4 pi over 3, which gives me a value of 96 pi in exact form. Now the area of the major segment, is equal to both of these things added together. So it's 36 root 3 plus 96 pi. Both of them are multiples of 12. So I can factorize that out. So I get 3 root 3 plus 8 pi. So that would be my exact answer for the major segment, for the area of the major segment. Okay, question 4. The figure below shows a square ABCD with side length 6 centimeters. The circular arc BD is drawn inside the square with center at C and the radius of 6 centimeters. Another circular arc BD is drawn inside the square with a center at A and radius of 6 also, so that the two arcs bound in the finite area shown below. Show that the area of the shaded region is 18 times pi take away 2 centimeters squared. Okay, so first thing I want to do is if I work out the area of this sector, so basically I'm doing, if this is called A, B, and C, then this part is A plus B. Okay, because this is 90, this is square, this must be 90 degrees. The radius is 6. Okay, so if I want to work out the area of this part, let me just shade it in. So if I want to work out this part, area is equal to half r squared theta, which is half times 6 squared times theta. 90 degrees is just pi over 2, which gives me a value of 9 pi. So that part is 9 pi. If I do now the other part, so if I draw the same square, now I'm doing the other arc, which is like this. Then because I've included B and C in this part, I'm working out B plus C. Now again, because the angle is 90 degrees there and the radius is 6, the area of this part will also be 9 pi. Okay, now if I add these two sectors together, if this, I call this 1 and 2, if I do 1 add 2, then what I'm getting is A plus B plus B plus C, which is A plus 2B plus C is equal to 18 pi. But because this is a square, the area of the square is equal to 6 times 6, which is equal to 36. And that is A plus B plus C. So I've got also A plus B plus C is equal to 36. Now if this is equation 1 and this is equation 2, then if I do 1 take away 2, A take away A will be left with nothing. 2B take away B will be B, which is what we're trying to find out. C take away C will give me nothing. 18 pi take away 36. So B is equal to 18 pi take away 36. And B is what the area of the shaded region anyway. So area of shaded region is equal to 18 pi take away 36. They're both in the 18 times table, so I can take the 18 out and I get that. And because area would be centimeters squared, which is what I wanted. Okay, next question. The figure above shows a circle with center at O. The straight line segment AB is a tangent to the circle at A, so the angle AOB is a third pi radians. Determine the radius of the circle given further. The area of the shaded region in the figure is 6 root 3 minus 2 pi. Okay, so first thing, if I want to work out the area of this sector, because if I work out the area of the triangle, and then I take away the area of the sector, I'm left with this shaded area. So let's work out the area of the sector first. So area of sector is equal to half r squared theta, which is half r squared a third pi, which is a sixth pi r squared. So that's the first part. The next thing I need to work out is the area of the triangle. Now in the triangle, because there's a tangent and radius meeting, that must be 90 degrees. So I've got a 90-degree right angle triangle. This is pi over 3. And we know this is the radius. Which, because I want to work out the area of the triangle, I need this base part. Okay, so I need to work out this. Let's call this x. Then because I have opposite and adjacent, I have to use the tan ratio. So tan theta is equal to opposite over adjacent. So tan pi over 3 is equal to x over r. And if you put tan pi over 3 into your calculator, you get root 3 is equal to x over r, which means x is equal to root 3r. That means the area of the triangle will be half base times height, which is equal to half times root 3r times r, which gives you root 3 over 2 r squared. The area of shaded region is equal to area of triangle take away area of sector, which is root 3 over 2 r squared, take away a sixth pi r squared. And because this is equal to 6 root 3 minus 2 pi, I can equate them. So this is 1 and this is 2. So equating 1 and 2, I get root 3 over 2 r squared minus a sixth pi r squared must be equal to 6 root 3 minus 2 pi. If I factorize the r squared in the left-hand side, I get r squared times root 3 over 2 minus a sixth pi must be equal to 6 root 3 minus 2 pi, which means r squared must be equal to 6 root 3 minus 2 pi all over root 3 over 2 minus a sixth pi. Now if you put that into your calculator, you end up getting r squared. R squared is equal to 12, which means r is equal to square root of 12. R is equal to, which is equal to root 4 root 3, which is 2 root 3. So it'll be 2 root 3 centimeters. Okay, the last question now. The shape shown in figure 1 is a pattern for a pendant. It consists of a sector OAB of a circle center O of radius 6 and angle AOB is equal to pi over 3. They've been labelled already. The circle C inside the sector touches the two straight edges OA and OB and the arc AB as shown. Find the area of sector OAB. Okay, first thing. So area of sector is equal to half r squared theta. We know the radius is 6 and theta is pi over 3. So if we simplify this, we get 6 pi area, so the units will be centimeters squared. So that's part A done. Find the radius of the circle C. Okay, now if at the point where AO touches the circle, we draw a line there, then we know that is a 90 degrees. Obviously it meets at 90 degrees. And also we know that it splits up the angle in two. So we have a triangle there in front of us. So hopefully this triangle will help us find R. So if I redraw this, so we've got right angle triangle. And because this halves it, the angle must be pi over 6, half of pi over 3. Okay, now what do we know? We know this is R. So this is R. Now we don't know where this meets AO, so we can't say anything about that. We know that is all 6, but we also know that is R. So that means this part must be 6 take away R. So this is 6 take away R. We've got opposite and hypotenuse. So using sine theta is equal to opposite over hypotenuse. Then we've got sine pi over 6 is equal to R opposite over hypotenuse, which is 6 minus R. Which means sine pi over 6 in your calculator gives you half. Half is equal to R over 6 minus R. If I cross multiply, then I get 1 times 6 minus R is equal to R times 2, which means 6 minus R is equal to 2R. If I take the minus R to the other side, I get 3R is equal to 6, which means R is equal to 2. Therefore, R is equal to 2 centimeters. The region outside the circle C and inside the sector OAB is shown shaded in figure 1. Find the area of the shaded region. So part C. If I want to find the shaded region, area of shaded region is equal to area of sector take away area of circle. So I've got the sector already, I need to work at the circle. So area of circle is equal to pi r squared, which is equal to pi times 2 squared, which is 4 pi. So area of shaded region must be area of sector, which is 6 pi take away 4 pi, which is equal to 2 pi centimeters squared.